Let's continue on with your island biogeography theory. By this point, you should have done the first part with the online simulation and filled in data chart 1 from the first simulation with the 2 large islands, the next simulation with 1 large, 1 small island, and the next simulation with 2 small islands at different distances. And then answered questions 1 through 6 and written your claim. Now let's go over the explain section. So I'm going to open up Google Earth to do this part. In your claim, you should have said something like this. Larger islands have more biodiversity, and islands that are closer to the mainland have more biodiversity because it's easier for animals to migrate when it's closer to the mainland, and bigger islands mean there's more of the probability of arriving there. Now let's apply this to islands of habitat on the mainland. So what does that mean? Let's look at Google Earth. So here's Google Earth, and here is Santa Clarita. Down here is the San Fernando Valley. If we zoom out, we can see where Los Angeles is. So down here's the greater Los Angeles area, Santa Monica, up here's Pasadena. Then up here's the San Fernando Valley. And here we are in Santa Clarita. So we are called the Santa Clarita Valley. We're in a valley. And the valley here is this, see this line? That's the Santa Clara River. And that is what makes the valley. And we have a lot of smaller valleys in our bigger valley, like Bouquet Canyon is a valley within the bigger valley. But if you'll notice, Santa Clarita is surrounded by wild areas, undeveloped wild areas. So people don't live, there's no roads, or very few roads, very few people, very few buildings. And so our biome here is chaparral. Now let's go ahead and focus in. We have places in our city where they didn't build houses or roads. See this one? It's kind of this little S right here, a little snake. They didn't build there. How come they didn't build there? It's probably too expensive to take this hill down. It wasn't cost effective. So all over our city, because we're a hilly city, we have places that they didn't build, like along here. This is actually a hillside. So they didn't build there. If we go to Saugus High School, here's Saugus High. My regular classroom is right here on the corner. Look at the S Hill. The S Hill with the big S on it has the pipeline. That pipe is actually water, the Los Angeles Aqueduct. It was swindled water about 100 years ago that goes to LA City. Not us, we're not LA City. So water goes through Santa Clarita to LA City. But you look, it's a piece of wild habitat. We call this an island of habitat. Over here, we have more islands. Look at this island, it's a little bit bigger, surrounded by houses and roads. So humans have created these islands of habitat. How have they created it? That's your first question. What did we notice? We built roads, schools, houses, aqueducts. Some of these islands are bigger, like Central Park. Now there's a lot of man-made parts of Central Park, like the playing fields. But surrounding it is wild areas. There's a cross-country trail that I've heard is a very hard cross-country trail. And we have this wild chaparral all throughout here. That's a big island in the middle of the city. So we have some bigger ones, some smaller ones. Let me show you the biggest one in the middle of our city right here. This is prime real estate right here. Right here is the middle of the city, very, very expensive real estate. How come nobody's built there? Well, I'm going to tell you why. Oh, by the way, this is the old Saugus Speedway where they used to race cars decades ago. And here's the curve, the IHOPs over here. This area, they built rockets in the Cold War right here, the Bermite-Whittaker site. And they spilled rocket fuel all over the soil. Or they buried it to get rid of it. So it's a hazardous waste site. It's called a Superfund site, and we'll learn about that later on. So we can't build here until the site's cleaned up, and there's a lot of people working on a way to clean it up because this is very valuable land. Okay, so we have a river. It's dry most of the year, except we have surface water during the rainy season. See this line? That's our river, Santa Clara River. It's one of the last remaining wild rivers in California, Southern California. Wild as in not cemented. The sides weren't cemented or the ground wasn't cemented, so it's natural. Some species won't cross this because it's mostly sand. So here's another barrier. That's your next answer. There are some natural barriers that create islands of habitat. So our river is one. Some species won't cross tall mountains either, so these are pretty tall mountains over here. They won't cross these either. Now let's talk about biodiversity in these islands of habitat in the middle of our city. So we have a pretty big one here. We have Central Park's pretty big. Then we have all of these little ones. Here's a little one right here. Here's another little one right here. They're all surrounded by roads and houses and buildings. So they're islands, little islands of habitat. Which ones do you think are going to have more biodiversity? The bigger ones or the littler ones? That's half of your answer to number 7. All right. The next half of the answer, when we talk about islands, we talk about distance from the mainland. So what does that mean when we're not on the ocean, right? Okay. Let's say the mainland in this analogy is all of this wild area surrounding our city. This is wild chaparral mountains. At the higher elevations, you actually get into some forests. All of this wild elevation, all this wild area. So now let's take a look. If we have Central Park here, and maybe we take a smaller little piece of habitat. Let's go back to the S Hill at Saugus High. It's long and skinny, but it's small-ish. Let's take a look at one maybe about the same size over here, though, near Mountain View area of the city. Let's see. Let's go to Mountain View Elementary School. This is another small island of habitat. It's totally surrounded by an elementary school, roads, houses, a playground, a park. It's cut off from here, but look how close it is. Look how close this piece of wild land is to this huge piece of wild land. So which would have more biodiversity? This little one that's closer to the big area, or the little one on the S Hill at Saugus High? That's right, it's going to be this one, since it's closer here. So animals, plants when they migrate, biowind, they're going to have a much easier time getting from this big wild area to this little wild area. They don't have to cross very many streets. They don't have to cross much human habitation to get here. So that is what I want you to think about. These are the answers to number 7. Making the jump from islands in the ocean to habitat islands, quote unquote islands, the little pieces of habitat surrounded by human development on the continents, is a jump in this theory. That's why we did the Google Earth activity. Now go ahead and stop the video, but you also need to read this article. The article is at the last page here. So the last page of your document is the article on island biogeography theory. When you're done with that article, go on and do the next questions. You can Google biodiversity hotspots, or it's in chapter 11 of your book. Watch this video, see how they tested the theory, and then we'll go to elaborate on a separate video. So when you're done with the next parts, watch the next video when we talk about land preservation in national parks.